So factoring is one of the many ways we can clean up a limits problem. Rationalizing is another one, and it's going to be helpful for us when we have radicals. So note that if I tried to do direct substitution right now, I would have a square root of 4 minus 2, and in the denominator I would have a 4 minus 4. Well, square root of 4 is 2, 2 minus 2 is 0, 4 minus 4 is 0. That's our indeterminate form. That's what we want to get rid of. So in Algebra 2, we had a technique for getting radicals out of the denominator where we multiplied by the conjugate. Here, I don't have the radical in the denominator, but I can still multiply by a conjugate. Remember, a conjugate is the same two terms, but an opposite sign in the middle. So I can multiply the numerator and the denominator by a conjugate here to just see if I wind up with an equivalent function that does have a limit with a determined form. So this is going to kind of make your Algebra 2 sides cringe a bit because we're about to put radicals back in the denominator. But it is going to work out nicely for us. So if we take a look at that numerator, that is a FOIL problem. We got our first term here and our first term there. Well, the square root of x times the square root of x, that's just x. The reason we multiply by conjugates is for the inside and the outside terms. So since we're doing FOIL, we'll do the outsides first. We've got a root x times 2, which is just 2 root x. And then we get our inside terms, negative 2 and a root x, which is a minus 2 root x. Notice those are opposites. Those are going to cancel. That's why we multiply by conjugates. Last but not least, negative 2 times 2 is negative 4. And so before I forget, those are gone. In the denominator, it's good to have sort of this holistic approach because you might immediately go, oh, maybe I should go ahead and FOIL the bottom too. Note that if I don't FOIL, I have an x minus 4 on the bottom and a root x plus 2 as well. Now that my inside and outside terms from the top are gone, this is just an x minus 4 in the numerator as well. Right about now, everybody wishes they had a smartboard. So note, if you FOIL out on the bottom as well, you're going to miss the cancellation that occurs here. So you always want to look at the problems holistically. Does anything jump out at you? Anything nice going on? In this case, sure enough, we got it. We were able to find something that cancels, and now we can check and see if direct substitution is going to work for us. So we have a 1 in the numerator, a square root of 4, which is just 2, plus 2 is 4. So we have found our limit. Quite nice. Let's take a look at another one. Jumping over to number 8, this is a lot more like something we would have seen in Algebra 2. We really don't want that square root of 4x down there like that. Radicals in the denominator, not supposed to happen. So the conjugate in this case is going to be 4x, I missed my 4, is going to be 4x plus 6. So we want to multiply both the top and the bottom by that and see what happens. So again, the conjugate was for the denominator there. So that's the one that I'm going to FOIL. My first term here, first term for the conjugate. So square root of 4x times square root of 4x, that's just 4x. And then we can start looking at inside and outside terms. I'm going to go ahead and just tell you, hey, 6 times the square root of 4x and negative 6 times the square root of 4x, those just cancel. Go ahead and save yourself the time. The reason we're doing this whole process is for inside and outside terms to cancel. Feel free to skip writing them. Negative 6 times 6 is negative 36. And we are good there. The numerator, I'm actually not going to FOIL. So I always want to go in and just double check, like, do I have to FOIL? Is there anything else that's jumping out at me here? And in this case, one thing that I notice, I have a 4 and a 36, so I can actually factor a GCF out of the denominator. I'm left behind with an x minus 9, and take a look at that. I have found something that cancels. So our goal is to find something to cancel off to get rid of that indeterminate form. And note, I wanted to put a 9 in there. I got rid of that x minus 9 term, so there's no longer a 0 over 0. So that is what I wanted to see right there. Something to cancel off and allow me to use substitution. So now I'm good for substitution. We can do 4 times 9 plus 6 all over 4. So 4 times 9 is a 36. The square root of 36 is 6. 6 plus 6 is 12. And then 12 divided by 4 will just be 3. So there we have it. Got ourselves a nice limit. Rationalizing is a bit tougher than factoring, but it's definitely just finding conjugates, taking a look at the FOIL, inside and outside terms cancel, and then seeing what else you can do to simplify the expression. Sometimes you have to look at one for a little bit. Maybe you try one thing, it doesn't work, go back, try something else. We'll take a look at another one down here. What do we have? Oh yeah, this one's fun. All right, so again, we have a problem where we can't just substitute that 0 in because we'd get a -3 times 0 on top, which is 0. 0 plus 1, which is square root of 1, minus 1, which is 0. That's indeterminate form. Boo! So let's go ahead and multiply by the conjugate. This is an uglier conjugate. Plus 1, 1, 1. I originally had a minus 1, so now I want this to be a plus 1. Alrighty. So once again, the denominator's there. That's where my conjugates are. So that's where I'm going to have inside and outside terms cancel off. So we're going to go ahead and start with our first square root of x plus 1 times the square root of x plus 1. Well, that's just x plus 1. Again, inside and outside terms cancel because we have 1 times that radical, -1 times that radical. So those are going to go away. And then our last terms, -1 times 1, well, that's just -1. So maybe you already see it. That's nice. In the numerator, I'm not going to, in that case, I wouldn't even have to FOIL. It'd be a distributive property in the numerator. I'm not going to do that just yet. I want to see if anything else nice happens. Spoiler alert, it will. Plus 1. All right. So note that in the denominator, I have a plus 1, minus 1. Goodbye. And now that my denominator is monomial, meaning one term, I can cancel off this x with this one. So we do wind up with a -3 times this sucker, x plus 1, plus 1, all over, oh, nothing. So we did go ahead, we got rid of that x. That is what we wanted because we wanted the limit as x went to 0. So we got rid of the factor that was causing our indeterminate form. So at this point, it's just a quick substitution. Very nice. 0. So the square root of 0 plus 1, that's just 1. This is one I might want to break down in the steps. So we have square root of 0 plus 1, which is 1. Square root of 1 is 1. We also have another plus 1 from the back. So 1 plus 1 is 2. 2 times -3 is just -6. This is one of those that at first glance looks really bad, but after things start canceling off, yeah, not that crazy. We'll take a look at one more of these, one of these rationalizing examples. Jump over to 10 here. 10, note, it is very similar. A lot of these feel like deja vu. So we'll go ahead and do this last one, and then we'll call it. So we have now square root of 14 minus x. The conjugate's going to be plus 4. 14 minus x minus x plus 4. All right. So once again, the reason we want that conjugate is we know inside and outside terms are going to cancel when we FOIL the denominator. So if it feels like I've done the same thing a whole bunch of times in a row, you're right. So let's go ahead and FOIL that denominator. square root of 14 minus x times the square root of 14 minus x. Well, that's the 14 minus x. That was the first term here, the first term there. Boo. And then my outside terms and my inside term, those are going to cancel 4 times the root minus 4 times the root. And then I will also have negative 4 times 4, which is a negative 16. So unfortunately, we don't have ones that cancel like we did in the previous example, but still not too bad. Like the previous 3, I don't want to FOIL that numerator until I see if anything nice happens. Well, let's see what we see. All right. So in the denominator, I do have a 14 minus 16. 14 minus 16. Well, undo that. All right, 14 minus 16 is a negative 2. And note that I could factor a negative 1 out of that binomial, leaving with negative 1 times x plus 2. So there is a cancellation that occurs. A bit of factoring helped us see that. Well, combining like terms and then factoring. Again, we might not have seen that if we FOILed out the numerator, so I don't recommend FOILing the non-conjugate piece, because usually you'll hide something that way. So in the numerator, we have the square root of 14 minus x plus 4. And in that denominator, it's just the negative 1. So one thing we can do to clean this up, really, is to sort of forget about that being a denominator. I guess the equal sign's coming with. And we can just say that it's the opposite of whatever comes out of this substitution. If you liked it better as a fraction, yeah, you can leave it as a fraction. So now that we got rid of that x plus 2 factor, we are good to use substitution here. So we'll have the opposite of square root of 14 minus a negative 2, which just becomes plus 2, plus 4. So the square root of 14 plus 2, hey, that's going to be a 16. Square root of 16 is 4. 4 plus 4 is 8. That negative sign makes it a negative 8. So there we have 4 examples of rationalizing in order to go ahead and find our limits. Factoring is definitely the quicker of the 2 methods. There are some other methods when you have indeterminate form, 0 over 0, or the other indeterminate form, which is infinity over infinity. We might have time to get to some of those towards the end of this chapter. If we don't get them this year, you will definitely get them in calculus. So at this point, that's as much as I want to get through while I'm in Detroit. So make sure you're trying those practice problems. Make sure you're checking all of your work using Desmos, using Wolfram Alpha, using your calculator. Get comfortable with all the tools available to you. Again, you won't get all the tools on a quiz or a test, but you still want to be comfortable using them because as you dive really deep into calculus, having all of that technology to back up your work can really help boost confidence and, make sure you get right answers, which is important too. So I will see you soon. Hopefully you enjoy this nice, beautiful vacation from me. I'm enjoying my vacation from you. Just kidding, that was sad. Go robotics!